Hello everybody, Adam Lusek here, and today we're going to be talking about small agents. Small agents is a library that came right at the end of last year, 2024, from the Hugging Face team. And essentially, what they've provided is a very simple, lightweight library that provides agentic capabilities for all sorts of language models, with a highlight on open source language models. This is super beneficial, as most of the approaches and agentic frameworks and workflows that exist and that we've covered on this channel tend to be more catered towards the closed source large scale providers, things like the GPT line from OpenAI or the Claude models from Anthropic. So when I saw that the Hugging Face team released something that's more specifically geared towards being applicable to open source language models, I knew I had to give it a shot. So over the course of this video, we're going to be walking through how to set up and work with agentic workflows in the small agents library, a little bit of the theory and reasoning behind some of the choices that they made, and more specifically covering their understanding and definition of agents, as well as their unique approach through these things called code agents. We'll implement all of these agents with all sorts of the different backend connections. We'll build out and show how they handle custom tooling and actual connections from your language model to the environment. A couple advanced features like implementing different planning steps, as well as, of course, multi-agent architectures, and a couple different tips, tricks, and integrations with the entire Hugging Face ecosystem along the way. So to get started, we'll first import a whole bunch of stuff that we'll be going over from the small agents package, which you can install by just running a simple pip command of pip install small agents. And so once we have that installed and our dependencies imported, what we're going to do is run the notebook login function from Hugging Face Hub, where we can pass in our Hugging Face account token, which will allow us access to any gated models through the hub. But with those few things out of the way, what we should start with is more the definition and idea of what an agent is in the small agents library. As we started to realize, the definition of what an AI agent or language model agent is tends to differ pretty much every single time depending on who you ask. So it's always worthwhile to see whatever program or package you're using's true definition of an agent is within it to understand the scope and usability. So, small agents defines AI agents as programs where LLM outputs directly control the workflow. Rather than having one blanket statement or one single definition, they rather go for the more popular approach these days, outlining different levels of agency or levels of autonomy across language model-based systems. Making this chart a little bigger that they provided in their documentation, they have going from the base level of no agency that a language model output has pretty much no impact on the program flow. The middle level might be that a language model output determines function executions, and then going up to the full levels of agency where the language model actually output controls iterations and program continuations, as well as maybe one agentic workflow starting another agentic workflow. And so outside of this reliance on language model-based logic, one of the core components as well is the use of tools. Tools aren't necessarily a new concept in this library. We've already seen things like function calling within OpenAI, Anthropic, and Gemini models, but tools are essentially defined functions that allow language models to interact with their environment. This means that a language model, instead of just generating text, can actually choose to take an action. These actions tend to be some sort of function that is executed alongside, maybe even a literal Python function, which we'll talk about in a bit, or some sort of API connection. And usually what happens is the language model will fill in the keyword arguments of said function that is executed, and then it has another step where it can actually observe the outputs. So not only can the language model then take an action through some sort of function execution, but it can also learn and augment its responses based on the results of that action. So to orchestrate this interaction, small agents employs the popular REACT framework, which stands for Reason plus Act. This involves making the language model go through a series of predefined steps, which tend to follow this process loosely. There's some form of an input phase where a user's query, context, and any sort of response instructions are passed to the language model. This then triggers a reasoning phase where the language model is instructed to generate a thought. This thought might be some sort of observation or planning for the next steps based on the context. It then leads into the action phase, where a language model has the ability to execute some sort of tool call, trigger a function, API, or any sort of sequence, and then post that we have the observation phase. The observation phase is where the output of those actions are returned back to the language model, and then the language model is able to either take additional actions or generate some textual response back to the user based on these. And essentially, what happens is this reasoning, acting, and observation loop is looped until either maximum steps are called or a final answer is reached and returned back to the user. Implementing this React framework is what allows us to really send off a language model on its own in an agentic manner to be able to do that advanced reasoning and problem solving. The React framework is a very popular one and is commonly used with different kind of tool calling agent approaches, things like ChatGPT and whatnot. But one of the key differences that we now need to highlight is the actual handling of tools in the action phase. I have a whole video where I break down tool and function calling as we're about to very briefly go over, and I'll have that pop up right here on the screen now. But at the core of it, most of what we've seen traditionally with function calling has been very JSON based, where essentially a data structure or some sort of pedantic data model is passed through to a language model as some form of tool. And the language model, when it wants to invoke one of these tools, will generate a corresponding JSON object as well that is going to show kind of the inputs and the different function names that it wants to call. So we can see that from this simple example from the OpenAI documentation of a get weather tool, the output, if the model chooses to use the tool, is going to be something that looks like this, where it's saying it's a function and it wants to use get weather as well as passing in a dictionary of the arguments. And so while this is kind of the approach that most of the major providers like OpenAI and Anthropic take with function calling and adding different capabilities like that to their models, this doesn't come without some limitations. Namely, through this JSON-based approach, this restricts the action space of the language model through these fixed function sets. There's a high maintenance burden for actually implementing and maintaining individual actions. There's a limited ability to actually compose multiple actions together. Let's say if one tool's output is dependent on a prior tool's output, and there's kind of no native support for intermediate state management and increased kind of complexity in the multi-step problem solving phase when using these tools. Essentially, at the core of it, having to go through from the start to use every single tool, fill out each of the keyword arguments, look and see what the output is, and then maybe once or twice run a couple tool calls in parallel. This can really be detrimental if you have very complex environments or need to compose tools together in a more effective manner. And then even more so, the act of actually being able to invoke and generate those JSON objects for function calling tends to be some fine-tuned behavior. So the models literally have to be trained on being able to do this specific JSON form of function calling. So to address a lot of these limitations and provide a framework that's much more easily applicable across a wider set of language models, what smolagents does is actually takes a code agents first approach. So blowing up this diagram, we can take a look at what the differences between the text versus code-based agent approaches are. And what we see here on the left is the very traditional text-based approach, where the language model might have some sort of thought. It will invoke an action. The action is returned by the environment, and then it has to do another action, and that goes on and so forth. But the main thought here is that if we have functions that tend to be code functions anyway, or some sort of API connection that can be executed in a code environment, why not just treat them as such? So that is what the idea behind the code agent actually is. Rather than handling function calls as kind of this text-based or JSON-based experience, we keep it literally as code. So rather than going through, using each tool and observing the output, What we can do now is use the language model's inherent ability to be able to write code, combine that with some sort of interpreter and compiler for actually executing that code, and then using that as our main workspace. So in this simple example here from the Codact paper, what they're showing is that instead of going through and using these different 5 available APIs in a series, like the LLM agent of the past does, the coding agent is able to just understand these as functions and then write a very simple loop here, which is then executed and the final result is displayed. This approach is super interesting and unique. I had never really thought about this and the effectiveness of it until looking through the details of the smolagents library. But really what this code-based execution provides support for is very granular control flow of things like if statements or loops if you need multiple calls to tools, very persistent data flow, things like variable storage or passing different variables along in a function, very, very advanced tool composition and different chainings, as what we can see here is the ability to actually directly compose the output of one function's output into directly another tool's input. And also, what we're able to do is also have much more robust error handling, because most language models these days, especially the larger ones, are trained on some form of coding and code understanding. And so having all of the different code errors and being able to debug in that way and regenerate to fix its response tends to outperform the kind of trial and error of a text-based experience. More specifically, smolagents is going to directly be using Python. And defining tools as Python functions allows these language models to write complete programs as their kind of interaction with the environment. All in all, this tool approach of actually having kind of functions instead of the JSON objects is a super unique and interesting approach, and it'll make a little bit more sense as we actually start putting together and demonstrating the agents. That being said, let's get into how you can actually start making them. Starting with our first connection, naturally, smolagents being a Hugging Face based package has direct integration with the Hugging Face Inference API. If you've been around on Hugging Face for a little bit and clicked in on a model, you've likely seen something here on the side that says Inference API and then either warm or cold or something here. And you can even interact with the models directly through this small interface. But essentially what this is Hugging Face hosts different models for the community. They tend to swap in and out from the Inference API, very popular or different models that are gaining traction, but it provides a serverless connection to all of these different models. And then of course you can create your own inference endpoint if you have kind of your own model that you want to host in Hugging Face's system. But what this means is that it allows us to use some of the latest and greatest models for free directly from Hugging Face. Of course, there are some rate limits for whether or not you're a paying or a free user of Hugging Face, but still, you can generally find some very capable models. So in our case, we'll be using the just flashed Qwen 2.5 Coder 32B Instruct, which is a language model coming out of the Qwen group that focuses on code generation, code reasoning, and code fixing. I thought that this would be a great example to show due to the reliance on code agents. So to get started with the Hugging Face API, what we'll do is we'll pass in the model ID to the HF API model class here, and then we will create the agent. So for our code agent, we are going to have tools, which is going to be a list of tools. We'll get into it a little bit later of how to define your own, but for now, what we're going to do is just add on the base tools. The base tools, which we'll also go into a little bit further, are going to be a web search and web loading tool. We'll also more explicitly define the model here, and then just to show you all a little bit behind the scenes, I set the verbosity to 2. So once we have our agent, we can .run method it, and I'll say, who is Adam Lusick, the AI YouTuber? And running this, we'll start to see some output. So looking through, we can see that we pass in who is Adam Lusek, the AI YouTuber, and we can start to see that the model produced a thought, which it says, so to find information about Adam Lusek, I will need to perform a web search. And so what it does is it wraps its code in this code block here, where it stores Adam Lusek info, uses the web search tool with the query Adam Lusek AI YouTuber. And so then we can see that the small agents framework will then execute this code, and we see the results of it here. So that is passed back to the language model, and then what it tries to do is from the search results, it has a little bit of a thought of what I might be focusing on, and then what it's going to try and do is use the visit web page tool. So now I actually didn't implement or install the right packages for the visit web page tool, but that was a little bit intentional because what we can see now is we get no output, which in this case might mess up a system, but since it is agentic, we can see that the model thinks that the visit web page tool might not be providing the expected content directly from the channel. So it tries again and it tries again, and then it determines that it's not going to find it. But it's starting to actually pull together some more specifics about myself from all of its web searches. And then finally, when we reach the max steps, it will synthesize down into a final answer that I have a YouTube channel where I share content related to AI, including videos on fine-tuning and other AI-related projects. It even found a little bit of my LinkedIn profile, my GitHub, and apparently my YouTube videos have gained significant popularity. Love to see that. We can look a little behind the scenes by dot methoding into logs and things like the system prompt, so we can start to see in the back a little bit of how small agents is actually instructing the language model to use things like code blobs and create thoughts and must plan forward to proceed in a series of steps. And then we can see a little bit of some few shot examples here coming from the prompt, as well as some specific prompting techniques here. Some funny stuff like rewarding. So we've initially been successful in connecting up an open source model to small agents, having it run as an agent, and even demonstrating a little bit of its reasoning capabilities and problem solving capabilities when something like a tool output doesn't go as planned. So following the Hugging Face Imprints API, what you might also be interested in knowing is whether or not you can still connect to things like OpenAI or Anthropic, and you certainly can. And the reason behind this is usually due to the OpenAI API specification. A lot of model providers and open source model providers have started creating APIs from their base URLs and endpoints that match the endpoints of the OpenAI API. This is super useful when creating a program that might rely very specifically on the OpenAI API spec, but you want to actually swap out the different models. It is possible. The OpenAI API actually allows you to point towards a different base URL. And so using this, what we can do is use another tool, Light LLM, which essentially automates the different insertion of these base URLs back and forth from the different providers. So all we have to do is pass in a specific model ID with an organization to the Light LLM model function here from small agents, and then Light LLM will handle actually calling out using the OpenAI API spec to that model. So right now I've got in Claude 3.5 Haiku latest loaded in here, but I have a couple examples of how some of the other providers like OpenAI, Gemini, and then even things like Fireworks AI. So loading through 3.5 Haiku, we're going to ask, what is Adam Lusek's subscriber count multiplied by the 118th Fibonacci sequence number? This should hopefully highlight a little bit further the different code capabilities. So we see that it does a web search for Adam Lusek YouTube subscribers, and let's see what it has. There we go. So it has then created a Fibonacci function to calculate the 118th Fibonacci number. And then so it found from one of my older posts that I had 4,000 subscribers, which makes sense that it might use that. And so it understands then from this executed code what the Fibonacci number is and what my inferred subscriber count is, runs that through, and finds the final answer. So by now, I'm hoping that you can kind of see the power of the code agent, where if we didn't have something like a Fibonacci function defined and connected up in this JSON or text method, we wouldn't be able to orchestrate or do kind of these complex multi-step maneuvers like this. Moving on to the latter half of the integrations, of course, we have Ollama coming into play. If you're unfamiliar with Ollama, it is sort of the leading way to get up and running with large language models on your own system. It provides a local way of running quantized language models efficiently on things like laptops and other consumer hardware. And so since Ollama actually follows the OpenAI API spec, what we can do is pass in our local endpoint. So when Ollama's running, it runs on a endpoint or a port here that is exposed, and we can pass that in as our API base still to the light LLM model. So in the back here, I have a very quick and easy Ollama server running, and we'll try and run through Llama 3.2 1B. So don't expect too much from this one, as it is a quantized 1 billion parameter model running on my MacBook Air, but let's give it a shot. So just kicking it off, we can already see that we're starting to load the model in Ollama, and then it should start putting out a bunch of post requests. It appears that it attempted to make a bit of a Fibonacci sequence function, but doesn't seem to have worked very well, and then it kind of goes off the rails because it's a little bit confused from the few shot examples. So, well, this does demonstrate that it does work with Ollama. Definitely Llama 3.2 1B is not the best model for this specific use case. So I definitely recommend running a little bit more of a capable model for these agentic workflows, but this is also good to bring up that not every single open source model can actually handle something like this. We saw very specifically that the 32 billion parameter code model worked very seamlessly, but it turns out that once you get a little bit too far down and too far squished, might not work so hot. And last but not least, smolagents integrates directly with the Hugging Face Transformers package. So what we're going to do is we are going to load directly onto a GPU via transformers the Llama 3.2 3B instruct model using the transformers models function here. So as I mentioned, I am on a MacBook Air, so this would definitely not load as it needs a decent amount of VRAM. So I have a Collab notebook running in the background here where I've gone ahead and installed and then also downloaded and loaded the model. So we can see that right now on our GPU, we have about 12 gigabytes being reserved from this 3 billion parameter model. One important thing to note before I show you the output here is that the actual code interpreter behind the scenes has a list of base authorized imports. So if a model tries to import a Python package, if it is not in the authorized imports, it will say that that doesn't work. So if you do have some packages that you trust and know won't mess up kind of your system, you can add them to your authorized imports by passing along this argument when making your agent. So after running find the eigenvalues of this lovely string here, we can see that our little Llama 3.2 instruct model tried to first import the linear algebra package, but we can see that it was an unauthorized import, and so instead it used NumPy and was able to get the final answers. So with those 4 examples of creating and running various forms of agents, you can see how smolagents interacts with the open source and also closed source too if you would like ecosystem very effectively. So now the remainder of this video will be talking about the various different inner components of smolagents, including things like tools, planning, and multi-agent architectures. Now that we understand how single agents work, we can now work on the different customization capabilities. Starting first with a little overview of how smolagents actually handles tools. As we've mentioned a little bit earlier, tools are those actions and the different functions that we have just demonstrated seeing actually being ran that the language model can actually choose to take, configure, or use to solve some sort of problem. As we also demonstrated, smolagent comes with a few built-in tools such as the DuckDuckGo search tool, but also the Google search tool if you have a Google search API key, a visit web page tool, and funnily enough, a speech-to-text tool that uses OpenAI's Whisper model through transformers. Loading these built-in tools are very easy. You just make an instance of it and then run through your query. So for this simple example, I'm just searching on DuckDuckGo how many McDonald's are in New York City, and it gives me back some snippets from DuckDuckGo. But creating your own unique tools and connections to whatever APIs you need is actually a pretty straightforward process. The easiest way to do this is initially to use the @tool decorator. So literally taking an existing Python function and then adding the small agents @tool decorator here will convert your function into the necessary format to use it as a small agent code agent tool and function in its environment if you have a few specific components. The first is, of course, going to be a clear name, as the language model is only going to understand what the different tools it has available to it are based on the text. So for my quick example here, I am going to have a convert currency tool, and I have named this very plainly convert currency. The second thing that you want are very robust type hints, both on the inputs and outputs. So we can see that we will input amount from currency and to currency. The amount's going to be a float, and then both of our currencies are going to be strings, and we're going to expect a float output. And then in our docstring here, we need both a description. So our initial description will be a description passed along with all of the other information about the function to the language model so it understands what to do. And this one is going to be convert an amount from one currency to another using this nice gentleman's free API, which can be found around here. And then finally, we also need to include args. And so these are going to be the arguments, and this is where we can pass in some additional argument descriptions. So you don't want to include actually the type hints in this arguments docstring, which you traditionally would, but that'll be handled from the type hints up here. But this is where you can actually put in more of the textual descriptions of what these arguments are. So for amount, I obviously have the amount to convert, source currency code, and target currency code. Then the rest of the function is just going to be whatever logic you have here, which in my case is going to be calling out to this API. So if we run this with convert currency of 100 from USD to euros, we'll see that we get 97.05 from 100. And if we dot into a few of these things, you can see that our convert currency function has been created into an object, and we can see the name, the description, and then the different inputs and items here, which I've printed out a little bit stylized. This is what's going to be passed along with the prompts to the language model so that it understands what it has available to it. If you want a little bit more control over your tool, you can also subclass their main tool class here and create a little bit of a more granular function here. So I'm making a new class called convert currency, which is going to inherit from the main tool class. And this is where we can then pass in specifically our name, our description, our inputs, which is going to be in a nested dictionary format here. So for each input, you'll have the name of the input, as well as the typing and description in a nested dictionary, and of course the output type here. And then each one of these classes that inherits from tool is going to expect a forward function. This forward is going to be essentially what's called when the tool is used in the environment. So I'm just going to be putting in pretty much exactly the same logic that we had in our original function here, but now in the internal forward function of this class. Using it is going to be similarly easy. We're just going to create the currency converter from the class here and then use the forward method, and we see the exact same output. To verify that this works, let's quickly load our Qwen 2.5 coder 32p instruct, pass it along the convert currency tool, and ask it what 500 Great British pounds are in dollars. So going ahead there, we'll see that it uses the convert currency. It outputs 611, and then our final answer is 611.66. Of course, Small Agents, being a Hugging Face first platform, has a very unique, different tool implementation. They actually implement a way to use Hugging Face spaces via the Gradio API as tools themselves. If you've ever used a Hugging Face space, which for example, this one is the Black Forest Labs Flux One Schnell, you can obviously just use it from this interface here, or you might see down below, use via API. And this is where you can actually see that the Gradio backend that this space is running on has the ability to be programmatically accessed via API. And smolagents makes this easy by putting in a .from space method, where you can pass in the ID of a space along with a name and description, and use that then as a connected tool in your smolagents agentic system. So I've gone ahead and put together an image generation tool that will be looking directly at this space here, as well as a quick tool that can use the pillow package to open and show those images. So putting together another demonstration agent here, we'll be using the same model, passing in our image generation tool and display image tool, and asking it to generate an image of a green basketball and show it to the user. So we shall see that it has the image generator. It prompts it to generate a picture of a green basketball. And then, wow, look at that. It pops up and is displayed to me. And we can see that it was able to do that by using the display image function here. And its final answer is that the green basketball image has been displayed. So I believe that this is a pretty neat way of actually integrating with the Gradio API and the existing Hugging Face ecosystem. So all sorts of good ways to be able to connect to existing ones. You can also share those tools that you make to the hub and grab them from spaces or define them more clearly as specific functions yourself in your own environment. So now with the understanding of agents and tools, let's look at another quick technique, planning. Planning is an optional argument that you can instruct the LLM agent to actually include one or more kind of planning steps during the actual execution that it's running. This can kind of help with these different complex multi-step tasks, or when a LLM agent actually needs to adapt its approach based on intermediate results. Smolagents approaches this by prompting the language model to create two parts of a plan, both a facts list, understanding what is known and what needs to be discovered, and an action plan, which is creating a step-by-step approach to solve this task. It then follows the general process of having some additional planning step, where the agent will analyze the task and create a list of facts, categorizing by facts given in the task, facts to look up, and different facts that might need to be derived. It will then create an initial action plan based on these facts and available tools, and then at some sort of specified interval, what we'll do is update the facts with what the language model has learned, given the observations from its interactions with the environment, and then create a new or updated plan based on the progress, remaining steps, any new facts discovered, and any available tools. So you can pass in the argument planning interval when you're making your actual agent here. And if you have none, which is default, then there's no planning. If you have an interval of 1, then it's every step, or 2 or 3 or 4, and that's every kind of n steps. Let's take a look at this in action. We're going to be using the same Qwen 2.5 coder 32B instruct with a planning interval of every 3 steps. I'm increasing the max steps to allow for some of these planning steps to be worked in, and if there's a little bit of confusion, because we're going to give it a much harder prompt of generate and display 2 images, one of the current rate of dollars to euros on a whiteboard, and Great British pounds to USD on a chalkboard. So hopefully some planning should help out with this. So kicking this off, we should see the initial planning start. So we're going to pass the prompt into the model, and we'll get back that, of course, initial plan right here. So we need to fetch both the exchange rates, generate the images, and then display both of the images. So then it runs into a little bit of a code issue, but that is no worries. It fixes itself, finds the dollar to euro rate and the pound to USD rate, and then it updates its plan. So it knows that it has all of the different conversion rates. It now just needs to run the generation steps. So it's first going to do the image generator of the exchange rate of USD to euro here. And we see that it gets the path to that out. So that was successful. And now it knows that it needs to do some other things here. So it does the image generator of the Great British pound to USD. So it's getting there. And that just got generated right there, at which step it will update its plan, and it knows now it just needs to display the different codes. So, wow, we see both of our images that were generated being displayed. Whether or not the images are good, that is up to the interpreter, but finally, at the end, we can see that this was successful. The cool part is we can see as the plan changes along the different thought process of the language model, and it observes what it has and what it needs to do. So adding in these different planning steps at different intervals can certainly help with much more complex tasks. But as your complexities grow, one of the things that we all know is that with more tools, more instructions, and much more confusing prompts being ran to agents, they tend to then degrade in performance. So what is better is to actually have multiple different specialized agents that just cover individual parts of a project and then putting them together through some sort of multi-agent framework, which is exactly what we'll do now. Of course, smolagents supports different multi-agent setups, more specifically, essentially taking an agent and creating it into an invocable function that a main supervisor agent can actually use. This is going to be using their managed agent class, which if you're interested in seeing the source code, you can click in on my notebook here. As mentioned, much of the reason of doing multi-agent setups in these different hierarchical frameworks is that across many frameworks, what we've seen is that SQL agents can get overwhelmed as their environment grows in complexity. Adding too many tools, situations, pathways, and other things to an agent tend to degrade this performance, as I just mentioned. So what we do instead is create a network of individual specialized agents that have their own subsets of tools, memories, and available actions. And so what we'll do is we'll take our prior example here and split it off into a couple different agents. So we'll have 3 agents in general. We'll have a currency agent, an image agent, and then a manager agent. To actually create these agents that can be managed and called like functions, we are going to be using the managed agent function. So we'll create a code agent just as similar, but then we'll pass it once again through this managed agent class with the agent, and then we'll also pass in a name and description, very similar to how we defined tools back a little bit ago. So we'll do that with a currency converter. So we just have a code agent that has a currency converter and understands that. And we'll also do that with an image generator. So it has a image generation tool and the display images tool. Once we have both of those agents here, we pass them along to a manager agent, which is just going to be a code agent that now has a list of managed agents, our managed currency agent and our managed image agent. And now we will run a very similar prompt through, generate and display 2 images, one of the current rate of dollars to euros, and another of the current rate of Great British pounds to Polish zloty on a chalkboard. So looking through our output, we can see the manager agent called the currency agent twice for both of the different conversions, and then we see a bit of a different interface. We see a new run of the managed agent where it has some different instructions here to provide final answers to the manager. And so what it'll do is it does the conversion currency, writes out kind of a final answer that has some short answers, some outcomes, and any additional context, which will be used by the manager for the final choice. And then we see our second run converting the GBP to PLN. So that all gets put back to the manager, which then moves on to the next step here. And we can see that it's calling the image agent twice, one to show a whiteboard and one to show a chalkboard with the respective texts here, which it will go ahead and do that and display and say that it was good, and do that and display and say that it was good again. And we can see then the different generated images, which are a little bit lacking, but still got generated nonetheless here. But you can see that it was a little bit more of a cleaner approach to actually running this issue compared to the aforementioned planning approach. So the specialization and being able to manage and run different agents in this manner tends to give some pretty decent results, and it's cool to see that it's all being done with open source models. So now with pretty much all of the frameworks and ways of interacting with these agents covered and out of the way, The final little perk that smolagents has is a direct integration with Gradio, which allows you to pretty much create a very quick and simple front end for different agents. So just creating a very simple code agent with the currency converter and then using their built-in command of the Gradio UI.launch, what we can do is see that it will open up a Gradio interface here, and I can ask something like, what's the pound to zloty ratio? And then nicely here, we can see that it displays the code all stylized and the execution logs all stylized. And our final answer is 506. And we can see all of the nice code, but in a nice Gradio interface, which you can then host on the hub, use via API itself, or any of the other benefits that Gradio has. But with that being said, I have a few thoughts that I wanted to specifically note about smolagents, and I wrote them down here. I think that smolagents really provides a very robust and reusable framework for building single and multi-agent language model systems. It has good integrations, some of the best that we've seen with open source providers to date, and the Hugging Face ecosystem shows, of course, much more unprecedented support for building with these open models, something that has been traditionally a little bit more finicky and less reliable compared to the major closed providers. One of the super important notes, though, that I have here is that these code agents provide a very strong approach to tool use and execution, leveraging language models' existing advanced code generation and understanding to more robustly handle and orchestrate different actions within the environment. Overall, I think a lot of the techniques used in smolagents are some of the best that we've seen yet in terms of wide model applicability and innovative improvements to different agentic performances. So with that being said, I'll have all the code in the description below, linked with additional resources for your further education and reading. But hope you learned something or got inspired by this video. If you liked the video, leave a like on the video. If you have any questions or suggestions for future content, leave them in the comments below. And if you want to see more like this, consider subscribing. Thank you and have a great day.